So let's look at example 3. It says using the midpoint rule with n equal 4, meaning 4 rectangles, approximate the area of the region bounded by the graph of 1, f of x equals 1 over x squared plus 2, the x-axis, and the lines x equals 0 and x equals 1. So in other words, what they're saying is find M4, again, 4 rectangles using the midpoint of the function 1 over x squared plus 2 on that interval 0 to 1. It wants us to round all answers to 3 decimal places, so we're just going to consistently round to 3 decimal places throughout the entire problem. Let's see what this looks like. Let's get going. This is going to be bad numbers. Again, it's the textbook. It's not my choice to use these bad numbers, but it gets us what we need to. So how many rectangles are we going to be doing? Well, it says it wants 4, so there's 4 rectangles. Let's think about which endpoint are we going to use? Well, we're going to be using the midpoint. Let's think about the width here. How do you find the width of each one? What's the right endpoint? 1 minus the left endpoint 0 divided by the number of rectangles, which is 4. So this is what, 0.25 if I write that as a decimal. We draw out our interval. Here's that interval from 0 to 1. That's where I care about. I need to draw 4 rectangles, so I need to break it up in 3 places. 1, 2, 3. That creates 4 rectangles. I need to label them by adding the width of each rectangle, which is 0.25. So that would be 0.25 on the first one, 0.5. 0.75, and then 1. Again, just adding 0.25 every single time. But the bad news is I need to find the midpoints of each one of those intervals to use as the height. So what's halfway in between 0 and 0.25? Well, that'd be 0.125. Between 0.25 and 0.5 would be 0.375. Between 0.5 and 0.75 would be 0.625. And between 0.75 and 1 would be 0.875. So those are the 4 values that we're going to be plugging into the function to determine the heights of our 4 rectangles. So again, we have our x values that we needed, which was 0.125. We had 0.375. We had 0.625 and 0.875. Those are my 4 x values. I need to find the height and then the width. And then that gives me the area for each one of those. Again, the width is always delta x, which in this case is 0.25. So each one of my areas I'm going to multiply times 0.25. Or sorry, each one of my heights I multiply times 0.25. And to find that height, we plug it in the function, which is 1 over x squared plus 2. Again, I'm going to be using my calculator for this one. I'll use the table feature on my calculator. I hit table. I type in 1 over x squared plus 2 in my table feature. Let me do that real quick. 1 over x squared plus 2. I go start, enter, step, enter, make sure I'm on ask. I plug in 0.125, 0.375, 0.625, and I go over and I use that double arrow button to give me the decimal. Again, I said we're going to round to 3 decimals in each one of these, so I'm getting 0.496. The next one I'm getting 0.467. The next one I'm getting 0.418. And the last one, when I plug in 0.875, I'm getting 0.362 if I round to 3 decimal places. So what do I do now? I multiply each one of those times its width. I have the height. I multiply it times the width. I get my areas. I'm getting, please double check my math, I'm getting 0.124 when I round to 3 decimals. I'm getting 117, 0.105. So again, I'm multiplying these and seeing what it equals. And in the last one, I'm getting 0.090. So that's the area of all 4 rectangles. Now what I do is I add those 4 together. and I'm getting 0.436 when we rounded to 3 decimal places for each of those. So that's my answer on the problem. The area estimated beneath the curve of 1 over x squared plus 2 on the interval 0 to 1 using 4 rectangles and the midpoint of each rectangle. I'm getting an approximate area of 0.436. Okay, let's try one more example here. It says, use the midpoint rule with n equals 4 to approximate the area of the region bounded by the graph of f of x equals x squared minus 1, the x-axis, the line x equals 2 and x equals 4. So what the heck does that mean using my notation? That just means we're using the midpoint in 4 rectangles, so that's M4. We have our function and we have our interval. That's all we need. So think about it. In here is 4 rectangles. What point are we going to be using? Well, the book uses consistently the midpoint. What's our width of each rectangle? Well, you do the right endpoint, which is 4, minus the left endpoint, which is 2, divided by the number of rectangles, which is 4. Again, I'm going to use my decimal version of this, so I'm getting 0.5 is the width of each one of these rectangles. I think about that interval. I start at 2, I end at 4. I need 4 rectangles, so I put 3 slashes. I'm going to label each one of them by adding that width every single time. The width is 0.5, so this would be 2.5, then we'd have 3, and then 3.5, and then 4, so that worked out. Again, what stinks is I want to use the midpoint of each one of these intervals, so let's look at the numbers. Halfway between 2 and 2.5, add them together divided by 2 is 2.25. 2.5 plus 3 divided by 2 is 2.75. 3 plus 3.5 divided by 2 is 3.25. 3.5 plus 4 divided by 2 is 3.75. So these are the 4 points that I'm going to use to determine the height of each one of my rectangles. So again, we need those x values, which was 2.25, 2.75, 3.25, and 3.75. Those are all the values I'm plugging in. I need to determine the height of each rectangle. I need to determine the width of each rectangle, which is going to give me the area when I multiply them. Okay. So the height, I need to plug it into the function, which is x squared minus 1. The width is always delta x, which in this case is 0.5. So I'll fill that in now. And again, I multiply the height times the width, and that gives me my area for each one of those rectangles. I'm going to use the table feature in my calculator. It wants us to round to 3 decimal places, so I'm going to round each one of these answers to 3 decimal places. So go into your table now, type in the function, the square root of x squared minus 1. Go ahead and hit enter, make sure it's on ask. Type in the numbers, so I'm going to type in 2.25, hit enter, 2.75, and 3.25. I can only do 3 at a time. And if I'm rounding to 3 decimal places, it looks like I have 2.016. The next one I'd have 2.562. The next one I'd have 3.092. And let me plug in 3.75 real quick. Looks like I'm getting 3.614 on that one. So that's my height of each of my rectangles. I'm going to take that height and multiply it times 0.5. Let's see what we get as the area rounded to 3 decimals. I'm getting, and please double check my math, 1.008, 1.281, 1.546, and 1.807 when I multiplied each one of those times that 0.5. So that's the area of the 4 rectangles. Adding those together, please double check my math. I'm getting 5.642. Again, if this was units, it would be whatever the unit is squared, but there's no units on the xy plane. So the area estimated beneath the graph of x squared minus 1, the square root of x squared minus 1, in the x-axis on the lines x equals 2 and x equals 4, using 4 rectangles and the midpoint for each one of those rectangles as your height, we end up with an area, approximate area of 5.642.